Here's assignment 9-6. We are going to do it together. And this hopefully will go from 1 through 15. So let's start with number 1. We're going to work it through together to have an understanding of what we're going to do. So when I want to do question number 1, all these questions have to do with different integration techniques, like a review lesson on integration. First thing I notice is it kind of looks awkward. You have a fraction, you have square roots. So I do want it to have a sense of being calculus friendly. So if I was going to do that, maybe the first step that would be good is instead of square root, write it to the 1/2. The second thing I notice is that if there's a monomial in the denominator, that gives me the direction that I can write that as 3 fractions. So there's one fraction. Here is the next fraction. And then here's the last fraction. And I'm going to write the last one instead of a fraction. I'm just going to write it as 3x to the negative 1/2. By writing it separately as 3 of them, I can then do some algebra. I can simplify it. Now, when I simplify this, I'm going to subtract the exponents. So 1 take away 1/2 is positive 1/2. Here, it just simplifies to 1. They just divide down. And then here, I can just do the anti-power rule. It's ready to go. So I can start there and do the anti-power rule. Negative 1/2. Negative 1/2 times 3. So negative 1/2 times 3 is negative 3/2. And I know these two negatives will eventually make it positive. Then add 1 to the exponent. So negative 1/2 plus 1 is positive 1/2, and then you're going to divide or times the reciprocal. Oh, why did I do that? Why am I multiplying? I meant integrating. Silly me. So to integrate, we have that 3 in front. We're just going to add 1 and then divide it. So it's not that we go negative 1/2 times 3. That's the derivative rule. I'm getting rusty too. What we need to do is we need to add 1 to the exponent, which is positive 1/2, and then divide or times the reciprocal. So we don't have a half in it. It's going to be 3 times 2. So let me write this over again. So we have the 3 here, and then when we go, instead of dividing times the reciprocal, that's where the 2 comes in. And that's what it looks like. And then after you actually integrate, we need that plus c at the end, but no more dx after you actually do the integration. So now let's go one at a time. Make sure I do this one right. So we have the 2 in front. We're going to divide by that. We're going to add 1 to the exponent and divide. So if you add 1, you get 3/2. Divide times the reciprocal. The antiderivative 1 is just x. And then we did this one already. So 3 times 2 is 6. Did I write down the question wrong here? Oh, this said plus, so this should have been a plus. So plus 6. And that's a great answer. You could also write that as 4/3. So number 1 is done. Number 2. Let me write it down. So we're going to integrate 2x plus 1 to the 6 dx. So step number 1 is understand where the hook or chain comes from. So from the base, the derivative is 2. That's the hook we need. And then to undo it, what fraction needs to be in front? Then once it's set up, the hook goes away. We start with 1/2 and then do the power rule. And the power rule, the anti-power rule, is add 1 and then divide. And that's fine. And then add c. Number 3. Move this up a little. All right, number 3. Where are we at? So we're integrating 3t squared subtract 1 squared dt. Now, for this example, if I take the derivative of the base for the hook, I get 6t. There is no like term in front where I could undo it with a fraction, so that's not the direction I can go. So the second thing I look at is there some algebra that I can do to simplify it. So if I just have a binomial squared, why don't I just expand it quick? So if you need to, you can draw a box and you can expand it 3t squared minus 1, 3t squared minus 1, and then multiply it out. So make sure you add the exponents when you do that. There is a technique to be able to expand it without doing a box like that. So if you went 3t squared and you square it, that would be 9t to the fourth. And then if you multiply it together and then double that answer, that's negative 6t squared. And then if you square the last number, that's positive 1. So that's the same answer as the box. Then for each one, you just integrate doing the power rule. So we have 5 and then divide. We don't have to simplify. Add 1 and then divide. And then 1 is just t and then plus c. All right, number 4. So for number 4, we're integrating the square root of ln y over y dy. So my first instinct for number 4 is to write it in a calculus-friendly way where you can actually see what's happening. So let's see if we can see this. So I know the derivative of ln y is 1 over y. So I see the connection there. It's kind of like a puzzle that you're trying to solve. So we have 1 over y. That's what this is in front. And then instead of ln and the square root, we're going to write that to the 1/2 dy. So I want you to see where 1 over y comes from. And instead of square root, it's written to the exponent 1/2. Now understand the derivative of ln y is 1 over y. And the hook is proper. So the chain is exactly what it needs to be. It doesn't need to be a fraction in front. And then the hook or chain can go away. And that's just the anti-power rule. So add 1 to the exponent. So 1/2 plus 1. And then divide or times the reciprocal plus c. Number 5. Here's a trigonometry one. So I know there's a connection between tangent and secant squared because I know the derivative of tangent is secant squared. So I see that connection already. So when I start to see that connection, maybe I can write this in a way then that would make sense. Now, if I write it this way, and I try to do the anti-power rule, you add 1, you get 0, and divide by 0, that's not the direction we're going to go. So instead, when I see a fraction, one thing we need to think of is it could be a logarithm. So what's the derivative of the denominator? Is it secant squared? It matches, because the derivative of 1 is 0. The derivative of tangent theta is secant squared. So actually this does match. So the answer is just ln 1 plus tangent theta plus c. Remember, the other thing we think about when we see a fraction is it could be inverse trigonometry, but it was not in that form. Number 6. That was number 6. Did I skip 5? No, number 6 almost looks the same. Haha. So, number 6, secant squared theta. And this time it's 1 plus tangent squared theta. So, what this makes me think of, 1 plus tangent squared theta, is this could be a trig identity, or I could do a substitution. So when I see 1 plus tangent squared theta, that's a Pythagorean identity. So on the side, I want you at least remember that sine squared plus cosine squared, if you add them together, it equals 1. That's a basic identity for trigonometry. If I want to create tangent, that's sine over cosine. So I'm going to divide everything by cosine. And when I divide everything by cosine, if I need to, I get tangent squared plus 1 is equal to 1 over cosine, and 1 over cosine is secant. So in other words, I'm just going to do a direct substitution. So the denominator, 1 plus tangent squared, is just secant squared. And if I can see that, well, it's over now. That divides to equal 1, and when I integrate that, the answer is just theta plus c. All right, number 7. Here's another one with secant squared. And this is 1 plus tangent theta squared. So is it a logarithm? The exponent 2 doesn't allow it to be a logarithm. And it's not in the form of inverse trig. And there's no trig identity to do a substitution. So I'm just going to write this in a calculus-friendly way. So I'm going to write this as secant squared and then 1 plus tangent theta to the negative 2. So I'm going to start in that direction. Remember I tried it the other way, number 5, and I realized if I add 1, you get 0 and then divide by 0, so I went in a different direction. But this one I can add 1 to. So the derivative does match, so the hook is correct. So my answer then is simply going to be, take the base, add 1. Now negative 2 plus 1 is negative 1, and then divide by negative 1, and then don't forget the candy or the cookie. All right, number 8. I said we're going to go to number 15 together. All right, so number 8, we have tangent theta, secant squared theta, and then 1 plus tangent squared theta. Now, the first thing I notice is we already did this trig substitution. So the denominator, we already did this. Is that off the screen? There it is. So I'm not going to go back again. But no, the denominator, you can just substitute in. So we just did this 2 seconds ago. 1 plus tangent squared is just secant squared. That's a trig identity. And that means these divide out, and all I'm left with is tangent theta. Now, tangent theta has its own rule, and it's ln, and it's negative ln, and it's negative ln of what? Think, 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 and it's negative ln cosine theta. So that's one of our rules we need to know. Number 9. And number 9, we're integrating 2x squared minus 4 over x plus 1 dx. The first thing I look at is I realize the degree on top is bigger than the bottom. Could I factor out this in a way where I could simplify it? Now, I can definitely factor out a 2, and that'd be x squared subtract 1. That's not going to lead me to anything. X squared subtract 2 is not going to simplify with x plus 1 on the bottom. So even though it's good to look to factor and simplify, this won't help us. So instead, because the degree on top is larger, I need to do long division. So I'm going to help you through that long division. So x plus 1 divided into 2x squared. We don't have an x, so I'm going to put a 0 there, just so that we keep our like terms together. So when I do this long division, 2x squared divided by x is 2x. Subtract for the remainder, that's negative 2x. Negative 2x divided by x is just negative 2. Again, multiply negative 2 times x, negative 2 times 1. When you subtract, be careful of the signs. You're adding here, so negative 4 plus 2. So the remainder is negative 2. So I'm going to come back up here. Our answer was 2x minus 2. We're going to put that here. Then we have a remainder, and the remainder was 2, but that has to be written as a fraction over x plus 1. Now, this should remind you of a logarithm, I hope. So first, 2x, if you do antiderivative of x squared, negative 2 is just negative 2x. And then the 2, well, it doesn't quite match yet, but we can put the 2 in front, or you could say the derivative of the base is 1. What was it before? What did it become? What you end up with is a 2 in front, and then ln of x plus 1 plus c. All right, number 10. We're almost there. We're getting there. So we're not doing the whole lesson today. The whole assignment today, but we're doing it together. That's way better, right, than doing it by yourself or doing nothing. So e to the exponent cosine 3u, and then sine 3u du. So the first thing I notice here is I have e to an exponent and something beside it. Now the hook for this is from the exponent. So what's the derivative of cosine? And the derivative of cosine is negative sine, and it needs a 3. So it's actually going to be negative 3 sine 3u. That's the proper hook that we needed. And I'm going to rewrite everything else in there. So the derivative of the exponent is negative sine 3u, and it has its own little hook of 3. So there we are. Now look to see what we have. Well, what was it before? And it wasn't negative, and it wasn't a 3. So before it was 1, so it becomes negative 1/3 is the fraction that we need in front. Now when we do that, this hook, the whole hook, goes away. We start with negative 1/3. Now the easy part, what's the rule for E? Copy it, and it's over. Plus C. All right, number 11. How many questions over here? You know what? For the first one, well, no, I'm going to do the first page. So it's a 50. So far, it's only been 15 minutes with me, so that doesn't too bad. So integrate x squared sine x cubed, and then 3/2, and then cosine x cubed. So the first thing I think of when I see this for number 11 is I recognize the base, oops, and what's the derivative of that base? So the derivative of sine is cosine, and it's cosine x cubed, and then the derivative of x cubed is 3x squared. That's what I notice. And then I just write down sine x cubed to the 3/2. Now that's the hook that I needed from this base. Now what was there before? Well, the cosine x cubed was there and x squared, but a 3. So what was it before? What it becomes? It needs a 1/3. Then I can circle this whole hook. It goes away. So we have 1/3. Then we do the power rule. In the power rule, you add 1 to the exponent. That's 5/2. And then divide or times the reciprocal, which is 2/5. And then plus C. Done. Number 12. In number 12, I see e to the 5x minus e to the x plus 2, and then e to the 2x dx. All right. So what technique, could you notice first? It's a fraction, but the derivative of the bottom, it's not a logarithm. It's not in the form of inverse trig, but I do see a monomial in the bottom. So that my first instinct is to separate it when I see a monomial on the bottom. So I have e to the 5x divided by e to the x. There's one fraction. I have e to the x divided by e to the 2x. That's another fraction. And then the last one I'm just going to write the way it needs to be written, which is 2e to the negative 2x dx. All right, so now I'm just going to integrate each one. Well, I'm going to do some algebra and then integrate. So the rule is when the bases are the same and you're dividing, you subtract the exponents. So that's all you have to do. So 5 take away 2, that's 3x. The next one, subtract. 1 subtract 2 is negative 1x, or just negative x when you subtract the next one. And then the last one, well, last one I'll actually do the hook involved. So the derivative of negative 2x is negative 2. So there should be a negative, which makes it a negative in front. Then this hook can go away. And now we're ready to integrate. Now, the rule is, well, first of all, let's make sure all the hooks are in place. So 3x, the derivative of that is 3. So the fraction needs to be 1/3, so the 3 goes away. For negative x, it needs to be negative. So the negative and the negative makes it plus. And then this one goes away. And then the simple rule is, for e, is just copy it. So we have 1/3 and then copy e to the 3x. Oops, no dx. Plus e to the negative x. And a plus and a minus make it minus e to the negative 2x plus c. All right, number 13. We're almost there. And then our first lesson is done together here. So we're integrating 4x. Now this one definitely feels like an inverse trig, doesn't it? Just the square root and so on. So if I was going to integrate this and understand it, and it's in the form of inverse trig, let's see how it works. So first of all, what does a equal in this situation for number 13? And the square root of 1 is 1. What does u equal? The square root of x to the 4th is x squared, and that means u prime is x. This here. So now look, what is the numerator? It's 4x. So what was it before? 4 over what it became, 1. So 4 divided by 1. So we need a 4 in front. And now it's completely set up to do arc sine. So what is the rule for arc sine? Oh, wait a second. The derivative of x squared is 2x. So this should actually have been a 2. What was it before over what it became? This will actually become a 2, because 4 divided by 2 is 2. So this is a 2. So we start with the 2, then arc sine, and then what goes inside is u, x squared, over a. So you can go x squared over 1 to follow the template, or just x squared, and that's it, plus c. All right, 2 more left, 14 and 15. So 14 is x plus 5. X squared plus 16 is not factorable, not a difference of squares. So now what do I do? So if you take the derivative of the denominator, could it match the numerator? Or what direction could we go? So is it arctangent or is it something different? So here's the challenge. If I take the derivative of the denominator, you get 2x. Even though that's like terms here, we have a binomial, and we can't do that with the binomial. If it was just x on top, we could then make it a logarithm and it's fine. But instead, we have to use another technique here. Because it's a binomial on top, I'm going to separate. So we're going to have x, and then we're going to have 5. I need a monomial in the numerator and make this easier. So here's another technique for that toolbox. What do I do when all the other options kind of go away? So now I can say the derivative of x squared plus 16x is 2x. This is going to be a logarithm. What was it before? What did it become? It needs a 1/2. The second one, now I can say maybe that's arctangent. And if that is arctangent, I'll do that on the side. A equals the square root of 16, which is 4. U is x squared, or the square root of x squared, which is x. And then u prime is 1. Now, what I have there is 5 and not a 1. So when I set this up with a 1, what was it before? What did it become? I need that 5 in front. And now we're just ready to plug in and get our answer, 14. So we have we got it. So start 1/2. This is a logarithm, so it's ln x squared plus 16. Notice in the answer key it's parentheses, but bars work. And then the next one, we start with a 5. Now arctangent has a fraction in front, 1 over a. So a is 4, so that's 1 over 4. Then arctan, and then inside arctan is u, which is x, over a, which is 4. And then don't forget the cookie, and we're done. All right, last one for this lesson, number 15. Good job deciding to work with me on this and not just copy the answer key. 15, so we're going to integrate 4 over t squared minus 4t plus 20. Now, if I take the derivative of the bottom, I get 2t minus 4. It's a binomial, so it's not going to match the top. So instead, for us to work this, what I notice is it could be arctangent if it was in the right form. And that right form would be like a binomial form, not a trinomial. Anyways, we're going to complete the square here. B is -4. We're going to divide by 2 and square to complete the square. So we have 4. Now in the denominator, what we're going to do is -4 divided by 2 squared, the answer is 4. So we're going to add 4. Then we have our 20, and we're going to subtract 4 to it, because it stays the same if you add the number and subtract the number in the denominator. Then the first parentheses here is a perfect square. So for this to be a perfect square and you factor it, what two numbers multiply to 4 and add to -4? That's -2 and -2, so I can write that as -2 squared when you factor it, and then 20 take away 4 is 16. Now this is in the form of arctangent. For arctangent, we write down a equals, and that's the square root of 16, u equals, that's the square root and square, they cross out, that's this t minus 2, and then u prime would just be 1, the derivative of t. So when I come back here, what I have in the numerator is 4, but what I need is 1. So I'm going to write down what I need, and then what was it before over what it became. So I have a 4 in front, and now we're ready to go. So it's going to start with a 4. Arctangent has a fraction in front, 1 over a, which is 1/4. Notice these actually just cross out, and the answer would just be 1 in front if you wanted it. And then arctan, and then inside would be u, which is t minus 2, over a, which is 4, and then plus the cookie, following the little formula for it. All right, Mr. G Math, over and out. Here we are, 1 through 15. Thank you for doing your work with me today.